Welcome back. This is Nick Agram again. Write tangent pi over 9 in terms of its cofunction. As you can see here, I pasted the cofunction, and cofunction of a tangent is cotangent. So if we have tangent pi over 9, that is equal to, we have cotangent pi over 2 minus pi over 9. Why? Because it says there, in my previous videos, I don't know which video is that, but I explained a little bit about why they are equal. Okay, there you go. And then we have, if I will expand this by 9, this by 2, then we have cotangent 9 pi minus 2 pi divided by 18, and then we have cotangent 7 pi over 18. Okay, next, sine pi. The cofunction of sine pi is cosine, so we have, I can use another pen, sine pi over 7 is equal to cosine pi over 2 minus pi over 7. So if I will expand this by 7, it's by 2 there, by 7, then we have cosine 7 pi minus 2 pi divided by 14. Then if we simplify, then we have 5 pi over 14. Okay, some more. Verify the identity of sine without of. Verify the identity sine a plus b in parentheses plus sine a minus b in a parentheses is equal to 2 sine cos alpha cosine beta. So sine there first. We have sine alpha cosine beta plus cosine alpha sine beta plus sine alpha cosine beta minus cosine alpha sine beta. Then this will become 0. Then we have 2 sine alpha cosine beta. Then we verified the identity already. Okay, verify the following identity. Let's see if we can do that. Sine alpha cosine beta minus cosine alpha, not beta, alpha sine beta divided by cosine alpha cosine beta. If I'm going to expand this, sine alpha cosine beta divided by cosine alpha cosine beta minus cosine alpha sine beta divided by cosine alpha cosine beta. So this will become 1, this will become 1. Then we have tangent alpha subtracted by tangent beta, which is the identity. Okay, we have here, for a climbing wall, a guy wire R is attached 47 feet high on a vertical pole. Added support is provided by another guy wire, S, as you can see in the figure, attached 40 feet above ground on the same pole. If the wires are attached to the ground 50 feet from the pole, find the angle alpha between the wires. Okay, we can start with the figure, as you can see here, if we find the tangent of beta, then we're talking about this angle, and we're talking about the opposite side, 47 divided by 50, the adjacent side. And then if we're talking about the next one, the hypotenuse is S, then we're talking about the beta minus alpha. It looks like the beta minus alpha is equal to, the opposite side of that is 40 divided by 50, or that is 4/5. Okay, and since we have the difference of two angles, so we can use this formula. We have tangent beta minus alpha is equal to tangent beta minus tangent alpha, because we changed the position, so we need to follow that position. Okay, 1 plus tangent beta tangent alpha. Okay, then we need to, what we need to find, if the wires are attached to the ground, find the angle that alpha. That is what we're going to find. So if we're going to solve for alpha now, then we need to multiply both sides of the equation by 1 plus tangent beta tangent alpha. So we have tangent beta minus alpha, not A, alpha, multiplied by 1 plus tangent beta tangent alpha is equal to tangent beta minus tangent alpha. If we multiply this tangent beta minus alpha to all the terms, then we have tangent beta minus alpha plus tangent beta minus alpha tangent beta tangent alpha is equal to tangent beta minus tangent alpha. So if we subtract both sides of the equation by tangent beta minus tangent beta, and then we add, we subtract also both sides of the equation, tangent beta minus alpha tangent beta. Oh, there is another way which is better. I'm going to subtract to erase, not subtract. There is a better way. Okay, a better way is that we're going to subtract instead tangent beta minus alpha, subtract tangent beta minus alpha, and then add tangent alpha instead. So this is 0, this is 0. So we have tangent alpha plus tangent beta minus alpha plus, not plus, multiplied by tangent beta tangent alpha. This is very complicated now. Is equal to tangent beta minus tangent beta minus alpha. Okay. Okay, as you can see, we have common factor here. We have tangent alpha there, and we have tangent alpha there. We can use that. We have tangent alpha. We have 1 plus tangent beta minus alpha multiplied by tangent beta is equal to tangent beta minus tangent beta minus alpha. So my tangent alpha now is equal to, if we divide both sides of the equation, then we can find that we have tangent. If we divide both sides of the equation by this term, okay, for quantity, tangent beta minus tangent beta minus alpha divided by 1 plus tangent beta minus alpha tangent beta. So for our alpha now is equal to arctan. Tangent beta is 47 divided by 50 minus 4/5 divided by 1 plus 4/5 multiplied by tangent beta 47 50 there. Okay, and then we have alpha there is equal to arctan. Oh, but we can use our calculator. I will use my calculator. I will show you my screen. There you go. We have arctan divided by, I think I need 47 divided by 50 minus 4 divided by 5. I need 3. I need 3 divided by 1 plus 4 divided by 5 multiplied by 47 divided by 50. Is equal to, syntax error. What is the problem? That is, alpha is 0.079. And remember, this is in radian. So if you want to know it in (0.79) in degrees, then we have this radian. So we have 180 divided by pi, and that is approximately multiplied by 180 divided by pi, approximately 4.5 degrees. Yeah, that was complicated, but it's worth the effort. That is in radian, and this is in degrees. Okay, and I think my examples are over, and for my next series of videos, I will be discussing the double angle formulas. I don't know why it is red there, because maybe I'm using the Swedish language right now in my computer. And thank you for watching. I hope you learned something, and I hope to see you in my next video. Have a nice day.